Hey everyone, and welcome back to this class, Cluster Analysis, Unsupervised Machine Learning in Python. In this lecture, I'm going to introduce you to the intuition behind k-means clustering and how it works. So firstly, we know that since this is a machine learning algorithm, we're going to be working on data. So let's try to visualize some data we might get. The first thing you'll notice about this data is that all these points are the same color. This is because we're doing unsupervised learning, so there are no classes given to these points. Each point is just a vector, and that's all we know about each point. We don't know if it should be red, blue, or otherwise. But there's one important feature of this set of data. What do you notice about it? Well, our human pattern recognition abilities allow us to immediately see that there appear to be three groups of data here. In other words, we don't need the data set to tell us that these three groups are distinct. Our own pattern recognition abilities allow us to see this very clearly. That's what we mean by unsupervised learning. It's unsupervised because nobody needs to tell us the answer. This is a key concept behind artificial general intelligence as well. If we're going to build an AI that can navigate the real world, practically speaking, it probably has to have some general intuition and pattern recognition ability, since it would be infeasible to provide it with training data for every possible situation it could encounter. So that's a very important point. We're using our own pattern recognition abilities to tell these clusters apart. It's not in the data itself. But now you may have noticed that what we just looked at was a very unique and very specific situation. The first limitation of this data was that it was two-dimensional. This is of course necessary because if we had, say, a 100-dimensional dataset, you wouldn't be able to see it. The universe itself only has 3 dimensions of space, so that's all you can see. Sometimes I get students that are not convinced of this fact, so if you're convinced that you can see beyond 3 dimensions, try drawing a 10-dimensional cube and see what happens. Now, why do I mention this? Well, most real-world datasets are not two-dimensional. Therefore, you can't see most real-world data. And hence, your own pattern recognition skills are not useful in this scenario. It would be nice if we had some algorithm to find clusters or groups of data that could work no matter what the dimensionality of the data is. Of course, that's what this entire course is about, so you can be confident you know the answer to this question by the end of this course. Here's another issue. In the original data I showed you, I generated it so that it would show 3 distinct clusters very clearly. But what if our data looks like this? Or what if our data looks like this? Now you can see the clusters are not so clear-cut. In general, we'd like to know, is the cluster I found good or not? And in this course, we'll answer this question as well. So as a first step into understanding k-means clustering, let's consider 2 sort of fundamental truths about the clusters in a dataset. Suppose I'm told that these yellow, purple, and green points are the centers of some clusters, and I'd like to know which center does this new blue point belong to. And I think it makes intuitive sense that this point, of course, belongs to the center that it is closest to. So to decide which cluster a data point belongs to, I pick the nearest cluster center. Pretty intuitive. Let's now consider the second fundamental fact about clusters. Suppose I'm told that these data points you see here all belong to the same cluster. Let's call them x1 to xc. We'd like to know what is the center of this cluster. Of course, that's just the mean of all these data points. This is also called the centroid if you're thinking geometrically. And as you know, the way to find the mean of a set of vectors is to add them up and divide by the number of vectors. That's how you find the cluster center. Now the big question. We have these 2 fundamental facts about clusters. Is there any way that we can combine these 2 ideas to give us a clustering algorithm? Now, believe it or not, these 2 fundamental facts are all you need to implement k-means clustering. It turns out, if I initialize the cluster centers randomly, that if I just repeat these two steps over and over, I'll converge to an answer. So just to recap, we start out by picking some random points as our cluster centers. Then I can use the fact that each point in my dataset just belongs to the cluster whose center it is closest to. So I assign all my data points to their nearest cluster center. Then, now that I know each data point belongs to a cluster, I can calculate new cluster centers based on all the points that belong to it. Then I go back to the first step, which is assigning data points to the new cluster centers again. Later in this section, we'll see visual demonstrations of how the cluster assignments and cluster centers evolve over each iteration. Let's recap this lecture since, while it was quite short, there were some very important ideas introduced. First, we talked about the fact that sometimes it's really easy for us to see clusters. We don't need the dataset to tell us the label for each data point. We can easily see which data point belongs to which cluster. That means we've learned to understand the data in an unsupervised way. Second, it's important to understand the ways in which that example was limited. Sometimes the boundaries between the data might not be so clearly defined, and more often than not, we won't be able to look at our data because our data won't be two-dimensional. So what we would like to have is an automatic algorithm that can find clusters for us, given any arbitrary dataset. Finally, we looked at two fundamental facts about clusters: the fact that each point should be assigned to the cluster it's closest to, and the fact that each cluster center should just be the center of each point that belongs to it. We saw that when we combine these two facts together, we get the k-means clustering algorithm.